So your 14.1 notes goes over counting, but it's not just counting, it's your fundamental counting principle. So what we're going to look at here are different ways that things can happen and how to solve them algebraically. If you look at this first example, it tells you that suppose that 3 towns, Ashbury, Brampton, and Carmichael, are located in such a way that 2 roads connect Ashbury to Brampton and 3 roads connect Brampton to Carmichael. If you look at this, you have to look at the different ways that this can happen and the different routes that you have from one place to another. From Ashbury to Brampton, we said that there's 2 possible ways to go. However, from Brampton, you have 3 different roads that go from there to Carmichael. So you start with 2 times or 2 ways to get to Brampton. And then you have 1, 2, 3 ways to get to Carmichael. So to find out the total number of ways that you could get from Ashbury to Carmichael would just be by multiplying, and you get 6. And you know this because if you go from Ashbury to Brampton with the first and then keep going from the outside, that's one way. If you go from Brampton and then use the middle way, that's the second way. Same way to start with, and then to the left way, that's now the third way. So that right there is 3. If you use the bottom route from Ashbury to Brampton first, that would be an additional 3 ways, and in total, you'd have 6. Okay. Another way of looking at this is drawing out a tree diagram. So you start at one location, and you have 2 routes from that location to the next. From there, you have 3 routes from each of them. So each of the 2. So in total, it would be 6 different routes. This tells you that if you were to suppose that 2 events occur in an order, if the first event can occur in m ways and the second event can occur in n ways, you would just have to multiply the 2 ways in order to find the total amount that you'd have. Your next example tells you that an ice cream store offers 3 types of cones and 31 flavors. How many different single scoop ice cream cones is it possible to buy at this store? So the number of ice cream cones that you have, there's 3 of them, so there's 3 types. The number of flavors that you have is 31. If you multiply these 2, you get a total of 93 different possibilities. The next part we're going to look at goes over your fundamental counting principle with subsets of a set. With these, the best way to do this is to look at an example. Your different ways of something happening is going to be your power in this case. So this is just factors. If you look at the third example that you see here, it tells you that a pizza parlor offers a basic cheese pizza and the choice of 16 toppings. So in this case, you have your base of 2, your toppings is 16, so it's just going to be 2 to the 16th power. So this is what I was saying you might need your calculator for. So if you raise that 2 to the 16th power, you get a total of 65,536. So next we're going to look at permutations. With permutations, it just tells you that a permutation of a set of distinct objects is an ordering of these objects, which means the order matters. Anytime you look at the word or see the word permutation, it means that the order matters. If we look at the formula that we're going to use for permutations, we have that n over n minus r. So that n with that apostrophe means that it's like let's say if it was 4 apostrophe, it would be 4 times 3 times 2 times 1. Okay. With your next example, it tells you that a club has 9 members. So you're going to start with 9 members. In how many ways can a president, a vice president, and a secretary be chosen from the members of this club? So if you are starting with 9 members, out of those 9 members, how many of them can be president? 9 of them. However, if one person was chosen to be president, how many do you have left to be vice president? That would be 8. If now 2 people are president and vice president, you will now have how many people to choose from to be secretary? 7. So we're going to multiply the 9 times the 8 times the 7. Nine times 8 times 7 gives us 504. Another way of writing this, it would be that 9 permutation 3. You have 9 total members. You have 3 positions that they will hold, or that will be held out of those 9 members. Kind of permutation that we're going to work with is a distinguishable permutation. That just means that you're dividing out the overlapping occurrences. So if any time it says distinguishable, you're dividing out the overlapping occurrences. So for example, if we have 10 balls where 6 are red and the other 4 are each a different color, how many distinguishable permutations are possible? If you look here, you have a total of 10 balls. If you have a total of 10 balls, that number that's going to be on the top is going to be that 10. Then 6 of them are red. The other 4 are each different color. So the 6 will be at the bottom. So that's exactly what it tells you here. Another way of looking at your distinguishable permutations is that n apostrophe over n sub 1 apostrophe n sub 2 apostrophe and so on. Okay? So again, these are just distinguishable permutations. For your example 7, it tells us to find the number of different ways of placing 15 balls in a row, given that 4 are red, 3 are yellow, 6 are black, and 2 are blue. So out of all, there's 15. So that's going to be your top number. Then you have 4 that are yellow, 4 that are red. So I'm going to put 4 red, 3 yellow, 6 black, and 2 blue. So on your bottom of your fraction, how many different options do we have? We have 4, 3, 6, and 2. Remember that top means that you're doing 15 times 14 times 13, 12, 11, 10, 9, 8, 7, 6, and so on. I'm going to stop at the 6 because I do have a 6 on the bottom. That's going to cancel out that 6 on the top. So other than that 6, I have 4 times 3 times 2 times 1. 3 times 2 times 1. And 2 times 1. So the 6's on the top and the bottom cancel out. And then you just have to simplify here. So up top, we have 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7. This gives us 181, 621, 4400. On the bottom, you have 4 times 3 times 2 times 1 times 3 times 2 times 1 times 2 times 1, which is 288. If we divide this out, we should be left with 6,306,300. Your last example tells you that given the word grammar, how many distinguishable permutations are possible. First, you want to look at the total number of letters in the word grammar. You have 1, 2, 3, 4, 5, 6, 7. So you have a total of 7. Now you have letters that repeat themselves. That R repeats itself twice. So there are 2 R's. The A repeats itself twice. And your M repeats itself twice. So when you go to write your problem out, your 7's going to go on top, and then that A, that R, and that M repeat themselves twice, so you're going to have the 2 3 times on the bottom. Remember up top, that's 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom, you have 2 times 1 times 2 times 1 times 2 times 1. Your 2's can cancel on the top and the bottom. On the top, that's 7 times 6 times 5 times 4 times 3 gives you 2,520. On the bottom, that 2 times 1 times 2 times 1 gives you 4. So dividing these out should leave you with 630.